This tutorial will guide you in completing the beginning of activity 1. It starts off on page 134, and there's also a teacher-made assignment that has a digital version. So the scenario that we're looking at is there's this situation here where there's a club of students who are studying business, and they're studying whether weather affects the business, the number of customers that come into their frozen yogurt shop. So they're wondering if, when the weather gets hotter, if they'll have more customers. So what you do first in this activity is you're going to plot one point at a time. And as you plot points, you'll answer these questions. So after you plot the first point, 45.97, you will answer this question reflecting on how you think a line would look that went through that point or reflected that data. And then once you plot the second point, 25.55, you'll answer question B. When you plot this third point, 60.85, you'll answer question C. And then you'll plot the rest of the data points. Once you have all 5 plotted, you're going to answer some more questions. So let's get started. So the first thing that you're doing is you're going to plot point 45.97. So imagine this scenario. In this scenario, temperature is on the x-axis, and so that is your x coordinate. It's also what we called, remember, in our very first unit, the independent variable. And then the number of customers is on the y-axis, your vertical axis. So this is your y coordinate. And this is what's called your dependent variable. So when students are looking at the temperature, they want to know if the number of customers depends on the temperature. That's why it's called the dependent variable. If they independently choose a temperature, will they be able to predict how many customers there'll be because the customers depend on the temperature? So let's go. Let's plot this first point. So the first point that we're plotting would look like this. It would look like a coordinate pair. So it would look like this, 45.97, for example. And all of the points listed are going to look like this. You're going to have an x coordinate and a y coordinate right here, the x and the y, the x and the y. All right, so we're going to go over to 45 on the x-axis right here, and then we're going to go up, up, up to 97. So here's 95 and just a smidge higher than 95. So here, about here is 97. Okay. And then we're going to, so this point is done. And now we're going to go down and answer this reflection question. So the question is, do you see a pattern? Is there a pattern? And if you had something straight, like a chopstick or a skewer or a pencil or a piece of spaghetti that is not cooked, so it's straight, where would you put a line? And if you think about it, right, we're not exactly sure where a line would go. It might go here, it might go here, it might go here. We're not exactly sure where the line goes because we don't have enough data. So that's what you're going to be, something like that is what you'll probably want to write for this question. Because if you have a line even if it goes through this point, a line could go through this point and start just about anywhere down on the y-axis. So you don't know what the correct slope of the line is, right? It could be anything in this range. So we don't know yet. We don't have enough data to say where the line would be. So now we're going to plot a second point. We're going to plot this point, 25, 55. So 25 is right here, and then go up to 55. So here's the second point. Right? And we have a little bit more data now. So maybe the line is like this, right? Maybe it's not. Maybe it's more like this or more like this, but we're kind of getting an idea that the line might be something like this. So having a second data point gives us an idea that maybe our line looks something like this, one of these, right? But we still don't know very much. So for the second question, you'll write about what you were thinking about when you plotted the second data point. Now let's do the third data point. We did the second point. Now we're going to do the third, 60, 85. So 60, 85. So go up to 85 right here. So now it's a little bit less clear now, right? Because it looks like our line will go through this point, maybe, but then which way would it go? So if our line was like this, would it be here? Would it be here? We're not exactly sure. It's somewhere in this area. So now it looks like our line is not going to be an exact science, right? All the points aren't exactly in a line, like doot, 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 right? There's a little bit of variation. So it looks like we don't have a perfectly straight line, but that we're going to have to estimate a line. And you'll write something like that about what you noticed after you plotted the third data point. You'll put that answer in box C. And then your next step is to continue plotting the rest of the data points. So in this tutorial so far, we plotted these three. You need to do this one, this point, and you need to plot this point. So you're going to plot 15, 37, and you're going to plot 100, 100. Then you'll scroll down here and you'll respond to question number 2. So use your model. So you'll have 5 points plotted here, and you'll use that model to predict what the relationship is between the temperature and the number of customers. So if you notice an uphill trend, right, you can draw a line using this line tool in TeacherMade, wherever you think the line should be, right? Maybe you think the line should be here. Maybe you think the line should be here. Wherever you think the line should be, put that line there, and then use that line to predict what the number of customers would be at every temperature. So for example, I'm going to pick my line, but don't copy my line, okay? Because I didn't plot the other points yet. So let's just say my line was like this. Pretend. I could make a prediction, because this says use your linear model to describe the relationship, and the number of customers, right? So I can see that the relationship is positive because my line is going uphill. And that means that as the temperature goes higher, so as the temperature goes up, the number of customers also goes up. Because see, as we went to the right with temperature, we also went up in terms of customers. So that's what they mean when there's a positive relationship. As you go up on the x-axis, your y's also go up. That's what having a positive slope means. So that should give you enough information to complete page 134. Happy mathing!